Welcome to the AXA Engineers podcast, episode 15. Today, we're embarking on quite a deep dive. We're tackling a topic that is, well, not just crucial, but really foundational for anyone navigating the complex world of large-scale infrastructure and development. We're talking about how to truly safeguard quality, ensure project integrity, and maybe most importantly, build unwavering trust in civil engineering outsourcing. Modern civil engineering projects are just magnificent beasts, aren't they? They demand incredible precision, really innovative solutions, and the seamless integration of global talent. You've got teams working across different locations, different time zones. Think towering skyscrapers, vast transportation networks. These things are like a symphony of specialized skills and incredibly intricate designs. But here's the thing, right? Beneath the surface of these huge visions, the biggest challenges, those sort of hidden risks, aren't always the obvious ones. They often lurk in the unseen processes, in those delicate interfaces where different teams, different technologies have to somehow come together perfectly.
As we unpack these insights today, we really invite you to join the conversation. We'd love to hear your thoughts, your experiences with quality assurance, especially in these complex engineering projects. Feel free to comment or share your questions below, or you can reach out to us on our social channels too. Your insights really enrich this discussion and help us all explore what truly matters.
It's fascinating, because when we talk about risk in outsourced civil engineering projects, the gut reaction for many might be to point fingers at, say, the individual contractor or maybe the budget constraints. But in our experience at AXA Engineers, and we manage over 1,000 projects every year, with a dedicated team of more than 80 highly skilled engineers, we've consistently seen something a bit different. The single most significant vulnerability often isn't the external vendor themselves. It's more subtle. It's the project's own internal quality process, or lack thereof. Think about it like this. A single, maybe seemingly minor miscalculation, if that gets replicated or just spreads across distributed teams that might be operating under slightly different standards, it can snowball fast. It can turn into a really catastrophic failure. And this isn't just theory. We've genuinely witnessed firsthand how this kind of oversight leads to staggering financial penalties, huge reputational damage, and ultimately it can completely derail even the most promising initiatives in civil engineering outsourcing, sometimes before they even break ground. So it becomes clear, doesn't it? The bedrock of any truly successful, resilient project lies deep within those proactive processes that govern quality. It's not just about the skills of individual players working in isolation. It's really about building a robust framework right from the very start, instead of, trying to patch up problems later on.
Okay, so that's a really interesting perspective. If the common idea of blame the contractor isn't the core issue, where exactly does this vulnerability truly lie? And maybe more importantly, what's the defense? What does a firm like AXA Engineers propose as the ultimate safeguard against these lurking dangers? Dangers that, as you said, can have absolutely devastating project-ending consequences. Because what we're touching on here, I think, is a fundamental shift in philosophy that AXA Engineers really champions. It's this principle known as the shift-left approach to quality assurance. And maybe to understand its power, we can think about it like this. Imagine you're developing, say, a critical piece of software, maybe for controlling a smart grid system. You discover a fundamental coding error right in the very first module when it's still just lines of code. Well, fixing it might take minutes. A developer spots it, fixes it, done. But what if that same subtle error, that misplaced function or wrong algorithm slips through, makes it all the way through development, maybe even testing into deployment?
And then it gets embedded in hundreds of interconnected systems across an entire city's power grid. Now, you're not looking at a few minutes of debugging, are you? You're facing potential widespread outages, massive financial hits, and a complete breakdown of public trust. The cost of fixing it and the potential for disaster has just grown exponentially. That analogy, I think, perfectly highlights the huge difference between finding and fixing something early versus way too late. And in civil engineering outsourcing, where the stakes are just inherently so much higher, this isn't just about efficiency, is it? It feels much more critical than that.
Precisely. It's absolute critical. The shift-left approach fundamentally redefines quality assurance. It's not seen as some final inspection gate, a last-minute check for errors just before delivery. Instead, it's an integral part of the initial design process itself. It's woven in seamlessly right from day one. And for civil engineering outsourcing specifically, this isn't just like a nice-to-have best practice. AXA Engineers genuinely considers it the only truly effective defense, the only one against the inherent complexities and risks you find in modern globalized project delivery. Think of it as moving from being reactive to being deeply proactive. When you treat quality control as just that final safety net, that sort of desperate attempt to catch errors right at the end, well, From AXA's perspective, that's basically an admission of process failure. It means the problems have already seeped too deep into the system, like a disease allowed to spread unchecked. Proactive QA, on the other hand, is an offensive strategy. It's about building resilience in from the absolute beginning. It's designed specifically to find and eliminate those coding errors or design flaws at the earliest possible moment. And that means long before those errors can contaminate later stages of a complex civil engineering project. This saves, obviously, huge amounts of time and money, but more importantly, it prevents potential catastrophes and protects public safety. This is exactly why AXA Engineers structures its entire service offering around this core principle. Quality assurance isn't the cleanup crew you call in at the end. It's a foundational element of the project strategy right from the kickoff. It's about engineering quality into the project's DNA, not trying to bolt it on later as an afterthought. And this early intervention, it's not just about saving costs, although that's a massive benefit, of course. It's really about preventing those systemic issues that can just cascade through a project, turning what should be minor tweaks into fundamental, costly redesigns. Like, take a large-scale master plan community project. If a basic mistake in the grading or the drainage plan is caught right in the initial design phase, okay, it's a matter of adjusting digital models. Relatively simple. But if that same error isn't spotted until, say, the earth-moving machinery is already on site and work has begun, now you're talking about halting construction. You might have to bring in heavy equipment to recontour huge areas of land, discard materials, face weeks, maybe months of delays. The financial hit from that late correction, it could easily run into the millions. It completely dwarfs any perceived savings from skipping that initial rigorous QA. And the reputational cost. Well, a project visibly bogged down in rework, that's immeasurable. This philosophy is just embedded in every single project AXA Engineers takes on because we fundamentally understand that true quality is built, not just inspected at the end.
Okay, this is where it gets really interesting, I think, especially for these complex civil engineering outsourcing projects. So imagine you've done your homework, you've assembled an absolute all-star team of highly competent vendors. Each one brings their A-game, top-tier expertise to a single massive project. Let's say it's a new smart city development. Individually, their work is stellar, meticulously crafted within their own little silos. But then the moment comes when you try to combine their efforts to weave all these distinct contributions into one unified whole. What happens when their excellent, individually perfect work just doesn't fit together? Suddenly you're staring at what we've often heard called a digital Frankenstein's monster, a surprisingly common and incredibly costly outcome in global engineering projects, where perfectly good parts are just fundamentally incompatible.
That digital Frankenstein scenario, it's a perfect, almost chilling illustration of a critical failure point in outsourced engineering. And understanding why it happens is absolutely key to preventing it. You could have, say, two incredibly competent civil engineering vendors. Maybe one's based in North America, the other's in Europe. Both get identical project briefs for different parts of the same project. Yet when they deliver, their work products are fundamentally incompatible. It creates an absolute nightmare for integration. And this happens frequently. It's an immensely costly outcome when that unified quality assurance framework is missing right from the start. The root cause usually isn't a lack of technical skill on anyone's part. It's the absence of foundational process standardization. Technical brilliance alone, you see, without that crucial standardization, becomes unreliable, especially when you're juggling the complexities of multiple independent teams trying to collaborate on one intricate project. Let's make it more concrete. Take an example from AXA Engineers' own experience. Picture a huge multi-phase land development project, hundreds of acres, planned to become a vibrant mixed-use community. For this, you naturally engage multiple specialists. One firm handles the meticulous site grading and earthwork plans. Another designs the complex utility networks, water, sewer, power. A third focuses on structural elements like retaining walls, maybe some bridges, underground parking. Each firm, as you said, brings deep expertise in their field. But this distributed, specialized approach introduces a huge variable. Each organization, if you just leave them to it, tends to operate according to its own internal standards, its preferred software versions, sometimes even its own terminology for things. So without a central unifying control mechanism, this decentralization systematically creates the conditions for project chaos. It's an integration nightmare waiting to happen where the design files themselves are essentially speaking different languages. The impact of these differences becomes painfully obvious when you look at the technical details. The grading contractor, for instance, might meticulously prepare their drawings using, say, the U.S. National CAT standard, NCS, for their layering system. That's a widely accepted industry best practice. Great. Meanwhile, the utility designer, equally competent, relies on their own proprietary in-house standard for layering. It uses different naming conventions, different line weights, different symbols that might not align at all with NCS. And maybe the structural firm is using a completely different software platform altogether with its own default settings for how data is organized. So when these individually perfect deliverables are finally brought together, when someone tries to overlay them in a master design file, the result is genuinely a digital Frankenstein's monster. You end up with CAD files and models that are, yes, internally correct, flawless even within their own little bubble. Every line, pipe, beam is perfectly drawn according to that firm's standard, but collectively. They're unusable when you try to integrate them. Imagine trying to merge a grading plan where storm drains are on layer S strand with a utility plan where the same storm drains are on layer civil util dray pipe. Just integrating these disparate data sets requires extensive, incredibly expensive rework. We're talking hundreds, maybe thousands of hours of manual retagging, relayering, reformatting digital information. This leads to delays and ballooning budgets, often adding hundreds of thousands, even millions, before any physical work on site can even start. It really is like trying to build a high-performance engine with precision pistons made to millimeter specs and connecting rods bored out to inch measurements. The assembly process and the whole project just grinds to a halt. And it's not due to lack of skill or effort from any team. It's a fundamental systemic failure in standardization and technical protocol. This, unfortunately, is where many outsourced civil engineering projects get seriously bogged down, tripped up by incompatibilities that, honestly, with proper planning and a robust QA framework, could have been entirely avoided. AXA Engineers' solution: robust QA framework for standardization.
Right. And this is exactly where AXA Engineers steps in to confront and resolve this challenge head-on. We do it by establishing a single, unambiguous source of truth right from the absolute beginning of a project. And this isn't just some vague goal. It's a meticulously crafted framework that touches every single aspect of the project. It goes way beyond just a general scope of work.
It defines and crucially rigorously enforces granular requirements. We're talking about precise, project-specific file naming conventions, no room for guesswork, mandating specific software versions so everyone's using compatible tools, establishing detailed material specifications that are uniform across all vendors, implementing standardized testing protocols that everyone must adhere to. By mandating this unified set of standards, effectively creating a common technical language for the entire project, AXA's quality assurance process ensures that every single deliverable, regardless of where it comes from, whether it's a site grading firm in Europe, a utility design team in North America, or a structural engineering group in Asia, integrates perfectly into the master project model. This meticulous alignment transforms what would otherwise be a disconnected group of independent vendors into a genuinely cohesive, unified project team, everyone marching to the same precise beat. And the profound benefit, it minimizes the risk of that dreaded integration failure at critical project milestones. This proactive, preemptive strategy prevents that costly chain reaction of delays, huge cost overruns, and nasty disputes that so often stem from incompatible data in civil engineering outsourcing projects. It essentially turns potential chaos into predictable, unified progress. It builds unwavering confidence every step of the way and allows the project to move forward with remarkable efficiency, this level of foresight and control. That's precisely why clients trust AXA Engineers with their most complex, most critical undertakings.
That sounds incredibly thorough. Really, building in that standardization to avoid the digital Frankenstein makes perfect sense. But let's be realistic for a second. Even with the absolute best processes, the most rigorous standardization, a team full of brilliant engineers, errors are just an inevitable part of any complex human activity, right? We're all human. Sometimes even the most sophisticated software has a tiny glitch. So if we accept that some errors will inevitably happen, how does a firm like AXA Engineers make sure that when something does go wrong, because it probably will at some point, you can quickly find that proverbial needle in the haystack, especially in a fantastically complex project? I mean, imagine trying to trace one single calculation error buried within hundreds of revisions submitted by various teams, different time zones, maybe months apart even. That sounds like an absolute investigative nightmare. It could potentially stall an entire project, couldn't it?
You've absolutely hit on a crucial point there. Acknowledging that human or computational errors are inevitable isn't a weakness. Actually, it's the foundation for building truly resilient systems. The real challenge then becomes, okay, how do you effectively manage and fix those errors without completely derailing the project? Because without a structured, transparent system, projects often run into what we sometimes call a black box of accountability. What that means is a critical error Maybe it's a flaw in a complex drainage calculation, a misinterpretation of a soil report, or a fundamental assumption about load-bearing capacity. It surfaces, but there's no clear ownership, no immediate path to figure out where it came from or how to fix it. And then the project just stalls, sometimes for days, weeks, maybe even months, while different teams are scrambling, trying to identify the source and correct it. All that lost time directly translates into lost money, lost momentum, and frankly, a lot of frustration across the board. I remember one instance, a large residential development project, a subtle error in a retaining wall design calculation, just a seemingly minor value, was embedded 3 revisions deep. It came from a subcontractor working in a completely different country. Without a clear audit trail, every single team involved spent days reviewing their own work, cross-referencing countless files, getting tangled in endless email chains, just trying to pinpoint where the discrepancy originated. That kind of needle in a haystack search just consumes enormous resources and can create real friction within a project team. AXA Engineers solution, transparent, immutable documentation trail, exactly. And strategic quality assurance, the way AXA Engineers meticulously implements it, resolves this critical issue using a transparent, immutable documentation trail. You can think of this system as the project's very own flight data recorder. It's a comprehensive, unalterable log that captures every single critical action and decision made throughout the project's life. It meticulously logs every single revision to any design document or calculation, every comment exchanged between teams, every approval granted, and it does this with precise timestamps and clear, undeniable author attribution. This creates a comprehensive, verifiable, and frankly, unimpeachable history of the project's evolution. From the earliest conceptual sketches right through to the final, detailed designs. So what this means in practice is, when an error, no matter how subtle or deeply buried, eventually does surface, the project managers don't have to launch some huge, time-consuming forensic investigation, sifting through mountains of emails and old file versions. They can quickly trace it directly back to its origin. Pinpoint the specific revision where the error was introduced, identify the exact author who made that change, and see the precise submission time. This allows for incredibly targeted, efficient correction rather than a broad, wasteful search party. This level of transparency dramatically shrinks the error investigation time. We're talking from days, or even weeks in some cases, down to mere hours, sometimes even minutes. And that efficiency is absolutely crucial for successful civil engineering outsourcing. It lets the team maintain momentum, address issues swiftly, and stay focused on delivering the project. It transforms what could be a major bottleneck and a source of blame into a swift, efficient resolution process. It keeps projects on track, on budget, and fosters a culture of clear accountability without things devolving into finger-pointing. It's really about building in the ability to learn and adapt rapidly, ensuring every detail is accounted for, upholding the highest quality standards, and reinforcing that bedrock of trust that is just paramount in our field.
Okay, this next part, this brings us to what feels like arguably the most critical dimension of quality assurance in civil engineering. We're talking about public safety, long-term integrity. It's not just about correcting mistakes after they've been made, right? It's about preventing them from ever becoming part of the final constructed reality. And we're not just talking about, say, a visible crack in a foundation. That's an obvious problem, tangible. We're talking about something potentially far more insidious, something that could be devastating precisely because it's invisible, like a flawed assumption, a hidden variable, or maybe a subtle miscalculation buried deep inside a spreadsheet somewhere, something that looks perfectly fine, perfectly compliant on paper, but is actually physically unviable or structurally unsound in the real world. The stakes here are just astronomically high. So how does AXA Engineers go beyond just ticking the regulatory compliance boxes? How do you ensure a design isn't just up to code, but genuinely safe, robust, and resilient for decades to come? Especially when, as you say, the most dangerous errors are the ones you can't immediately see.
You've articulated the absolute core of the challenge right there. The most dangerous errors in civil engineering projects are almost never the visible ones. They are precisely those latent errors, those flawed assumptions or subtle miscalculations buried deep within design documents. They might appear perfectly compliant on paper, meticulously checked against every relevant code, but in reality, they're physically unviable or structurally vulnerable when built. These errors often relate to incredibly complex factors: the precise geotechnical properties of the soil underneath, maybe the long-term behavior of specific materials under unique environmental stresses, or even subtle misinterpretations of dynamic forces like wind or seismic activity. They represent the single greatest existential threat to a project's long-term integrity and, critically, to public safety. And identifying these issues after construction has begun, or even worse, after the structure is complete and in use, well, it's not just impractical, it's often impossible without destructive testing, and in many critical situations, it's simply not an option without creating immediate, widespread risk. So the only truly strategic defense is prevention, preventing them from ever becoming part of the final design documents in the first place. And this necessity is exactly why that shift-left principle we discussed earlier becomes absolutely paramount for safety. It's about moving quality assurance from being a final check to being an integral, proactive part of the initial design process. Think about the cost differential. Correcting a flawed design assumption at the conceptual stage. Minimal. Maybe a few extra hours of an engineer's time running simulations or refining a calculation. But the cost to fix that same error after concrete's been poured, steel's been erected, or an entire network of underground utilities is already in the ground. It's astronomical. We're talking not just financially, tens or hundreds of millions of dollars potentially, but possibly in human lives if a critical failure occurs down the line. This is precisely why firms like AXA Engineers structure our entire service model around this principle. QA isn't the cleanup crew. It's a foundational part of the strategy from day one, specifically designed to prevent these latent, potentially catastrophic failures. AXA Engineers' proactive QA protocols. This proactive approach directly addresses public safety risks by going far beyond simple regulatory compliance. Because, let's face it, a design can indeed check every single required box in a building code, follow every letter of the law perfectly, and yet still contain a fatal weakness that a superficial review would completely miss. AXA Engineers' proactive QA protocols are specifically engineered to counter this. We actively stress test designs through a series of rigorous, multi-layered examinations. These go deep into the underlying assumptions, the calculations, the material choices. These aren't just simple checkbox exercises, they are profound explorations designed to uncover a design's true resilience or lack thereof. These protocols include things like structured peer reviews, but critically, these are conducted by engineers who were not originally assigned to that specific part of the project. This brings fresh, unbiased eyes to the table, challenging assumptions, identifying potential blind spots that even the most skilled project teams might develop simply from being too close to the work. We also incorporate advanced simulations to model how the design will perform under extreme conditions. This could involve sophisticated finite element analysis, or FEA, to predict how structural parts will behave under unexpected loads. Or maybe computational fluid dynamics, CFD, to analyze wind and water flow around complex shapes. These simulations effectively push the design to its theoretical breaking points within a virtual environment, identifying potential vulnerabilities long before any physical construction starts. Furthermore, we perform detailed constructability analyses. Experienced field engineers review the design to make sure it's not just theoretically sound, but actually physically achievable on site, using available materials, standard techniques, feasible construction sequences. This roots out assumptions that might look good on paper but are impossible or prohibitively expensive to execute in the real world. It ensures the design is truly buildable as intended. This multi-layered mechanism is what genuinely translates abstract regulatory standards into infrastructure that is resilient, safe, and genuinely durable for the long haul. Let me give you a powerful example. Imagine a major cable-stayed bridge project designed to span a wide river. In the initial design, perhaps a subtle miscalculation of harmonic resonance was overlooked. That's the tendency of the bridge to oscillate at certain frequencies under specific wind conditions. Now, the design might have been perfectly compliant with all static load requirements, seemed totally robust on paper, but a truly proactive QA process, one involving dynamic simulation, which is a specialty of firms like AXA Engineers, would have identified that specific vulnerability. Such an analysis would reveal the potential for a catastrophic wind-induced structural failure, maybe similar to the infamous Tacoma Narrows Bridge collapse. By detecting that latent error early, through rigorous simulation and expert peer review, our process would allow for design modifications. Maybe changes to the bridge's aerodynamic shape, maybe adding damping mechanisms. This would prevent what could have been a multi-billion-dollar disaster and avert truly tragic consequences. That directly demonstrates the immense, often hidden value in civil engineering outsourcing when quality assurance is elevated to this proactive, preventative level. It's really about building for tomorrow's unpredictable challenges, not just checking today's compliance boxes, and ensuring the safety of generations to come.
That's a profoundly important point about preventing those catastrophic failures before they even become a whisper of a design flaw. It really, really highlights the stakes involved here. So, okay, let's zoom out. What does all of this rigorous standardization, the transparent accountability, the proactive safety focus, what does it all mean for the bigger picture?
Beyond just avoiding costly mistakes and ensuring public safety, how does this disciplined, shift-left approach to quality assurance actually translate into a firm's market standing? Its reputation, its ability to forge those lasting client relationships in what is, let's be honest, an incredibly competitive world of civil engineering outsourcing. Because ultimately, a company's success, its ability to win future work, it's built on more than just having the lowest initial price, isn't it? It's got to be about long-term value, sustained trust, consistent reliability.
That's exactly the ultimate outcome, isn't it? This proactive defensive quality, meticulously engineered from the ground up, it naturally evolves. It goes beyond simply avoiding failure and becomes about actively building an elite institutional reputation. And the long-term value of consistent, predictable, and importantly, provable quality, well, it just cannot be overstated, especially in an industry like civil engineering where project life cycles are often measured in decades, not months or years. You're literally building legacies that need to stand for generations. We can really see this clearly by looking at two contrasting scenarios. They starkly highlight why AXA Engineers' approach isn't just a best practice, but a critical, fundamental differentiator in the civil engineering outsourcing market. Scenario 1. The short-term focus, what I'd call a Pyrrhic victory. Imagine an engineering firm. Their main priority is immediate speed, maybe shaving costs up front by minimizing investment in that rigorous front-end quality assurance. They might initially win bids because, yeah, they can offer a lower price. That appeals to clients who are under intense budget pressure. However, inevitably, their projects become plagued by a predictable cascade of problems. Contractors on site are constantly issuing requests for information RFIs. Those endless questions that pop up when plans are unclear, contradictory, or just plain wrong. This leads to a steady stream of costly change orders to fix design flaws discovered mid-construction. And then you get the inevitable, often bitter, client disputes over who pays for the expensive rework, the delays, the budget blowouts. This approach, sadly, quickly builds a market reputation for unreliability and inefficiency. Clients learn the hard way that whatever they thought they saved up front on that lower bid, they end up paying for many times over, in agonizing delays, massive cost overruns, and just constant headaches throughout the project. So in the long run, this firm struggles. They find it hard to get repeat business, they often get locked out of the really high-value, high-stakes projects, and their market standing just slowly erodes in the competitive landscape of civil engineering outsourcing. Scenario 2. AXA Engineers' approach, building the foundation of enduring trust. Now contrast that with a firm like AXA Engineers. Instead of cutting corners on QA, AXA makes a profound strategic investment in a robust, transparent, and continuously improving quality assurance system. And this isn't just some internal memo, it's a visible, verifiable commitment to excellence. It's recognized by industry authorities, it's integrated into our technology partnerships, for example, with leaders like Autodesk. The significant upfront investment, even though it might mean our initial bid isn't always the absolute rock bottom lowest, fosters long-term collaborative partnerships. Partnerships built on an unshakable foundation of validated trust. Clients understand they aren't just getting a set of drawings, they're receiving the meticulously crafted output of a rigorously tested, continuously refined system. They gain confidence, real certainty in the accuracy, the reliability, the constructability of every single drawing, calculation, and specification that comes from AXA Engineers in their civil engineering outsourcing projects. And this unparalleled client satisfaction, this superior reputation, it's not an accident, it's not a lucky byproduct. It is, in fact, the precisely manufactured output of a strategic, deeply ingrained QA system. AXA Engineers' system is meticulously engineered to ensure that every single deliverable reinforces the client's trust. It transforms what could be just transactional one-off projects into enduring, strategic professional partnerships. In the fiercely competitive world of civil engineering outsourcing, a firm's demonstrable, consistent, and provable commitment to quality. That ultimately becomes its most powerful, most sustainable, and truly invaluable market differentiator. It's that silent, consistent promise that ensures not just project success, but also lasting business relationships, repeat engagements, and an unparalleled standing in the industry. It's the confidence that allows clients to move forward not with their fingers crossed, hoping for the best, but with absolute certainty. So if we really connect all these threads, looking at the bigger picture, the undeniable hallmark of a leading civil engineering firm like AXA Engineers isn't just the grand visible projects it delivers. It's also, crucially, about the profound failures it anticipates and meticulously prevents through a disciplined, unwavering quality process. Quality assurance, therefore, has to operate not as some separate department or a late-stage review function, but as the strategic backbone. the very nervous system, if you will, of every single project, right from conception through to completion. This philosophy fundamentally underpins and elevates AXA Engineers' reputation, a reputation built on consistently shifting quality left, rigorously enforcing standardization across all teams and deliverables, and fostering crystal clear, unassailable accountability at every single stage of civil engineering outsourcing. It's truly about building trust, one meticulously checked detail at a time, creating a legacy of reliability that clients know they can depend on, project after project, decade after decade.
So reflecting on all that, what does this really mean for your next big project? When you're evaluating potential civil engineering outsourcing partners, don't just get dazzled by the price tag or their glossy portfolio of finished structures. You need to dive deeper, look under the hood, ask yourself, is their quality assurance framework genuinely robust? Is it truly built on a standardized shift-left approach? Is it specifically designed not just to catch issues, but to actively anticipate and prevent those critical errors, those costly delays, those potential catastrophic failures before they even get a chance to materialize? The answer to that profound question could very well be the single most important factor in your project's ultimate success, its safety, its long-term integrity, and frankly, your complete peace of mind throughout the entire process. Choosing a partner like AXA Engineers isn't just selecting a vendor for a single project. It's really making an investment in a promise of reliability, excellence, and trust that truly stands the test of time. If you found this deep dive valuable today, we highly encourage you to like, share this, and subscribe to the AXA Engineers podcast.
And we'd absolutely love to hear from you. Share your own quality assurance challenges, your successes, maybe your experiences in the comments section below. Your insights really fuel these valuable discussions and help us continue to bring you the knowledge you need in this field. Thank you so much for joining us today on The Deep Dive.